So we have a program that can start with forces, find accelerations, use them to update positions and velocities, and therefore represent any sort of motion that we could generate at constant acceleration. We figured out how to put arrows on that to represent different quantities we might like to see. What I'd like to do now is add a plot. Plot is not the most intuitive sort of code here, so I'm going to walk you through it. I'm going to initialize the plots up here. I'm going to call them plot x, which is just an arbitrary name for this plot. I'm going to plot the x position in a little while. The function is g dots. I don't know what the g is for, but the dot is a scatter plot. It's going to put dots in the locations of the x positions of the ball. I'll set the color of that plot up here, and then we'll just let that be, and we'll use it. We'll call it down later. I also want a plot for the y component of the motion, so I'm going to repeat the same command here, except we'll let this one be blue just so we can tell them apart. I think we're also matching the colors in Logger Pro by doing this. Okay, then down inside the loop, now that we've created these two objects, plot x and plot y, down inside the loop we can write things to them. So here I'll have another section of code that is update plots. And I want to add, every time the loop runs, I'm going to have an x position and a y position, and I want to plot both those positions on the plot as a function of time. So to plot x, I'm going to call the plot feature of that object, and I want to put a dot at a position equal to, let's see, the horizontal axis would be time, t, and that's part of my loop. And then the plot I want to point would be at the ball's x position. So ball1.pos position dot x. We'll pick that out. That will place a dot on plot x at a position of tx. Okay. I also want to update the y plot. So here, let me give myself a little space. We'll do plot y dot plot, same idea. Add a position equal to horizontal position will be t time, vertical position will be ball1.pos.y, and I'm going to place a dot on plot y at a position of ty. Extra I there. Okay, let's see what happens when we run. There's our motion, there's our giant acceleration vector. If we look down below, we should see the plots. And these should look pretty familiar. We've plotted the x component of the motion and the y component of the motion at the same time. In x, it started at -5, and it moved at a steady pace in the positive direction because there were no forces in that direction. There was no acceleration, so this is Newton's first law. And then in the y dimension, we do have a downward acceleration. We started with an upward velocity, which is being reduced by the acceleration as it reaches a peak. And then the ball speeds up as it travels in the downward direction. So of course you could use these plots to plot any property that you like. Maybe if I don't care about the position of the ball so much, I could instead plot the velocity of the ball as a function of time, or the acceleration of the ball as a function of time. Now both those things, acceleration and velocity, are vectors. And so if we're going to put a point on the plot, we can't put the entire vector in one space on the plot. We'll have to choose what component of that property we'd like. So for example, I could take the y component of the velocity, that picks out the second piece of that vector, and plot that as a function of time. And down here I'm seeing that's right above 10, so that's right at 9.8 meters per second downwards, which is just what we expect. Here I'm still plotting the y position of the ball on plot y. Maybe a little more interesting would be to plot the y velocity of the ball. And here I could plot the x velocity of the ball, just like this. Hang on, let me put the x on the x plot and the y on the y plot. That makes a little more sense. Run that program. And as the ball moves, it is traveling 10 meters per second at a constant rate in the x dimension. But in y, the velocity is being reduced by the acceleration. So here's where it drops through 0, and then here's where it enters the negative. So you can be creative with this. Any kind of product that you want to get out of your plots, any result that you want some kind of quantitative data for, you can choose to represent those in a plot.